Hello friends. Welcome to Computer Fundamentals and C Programming tutorial. In last video we have seen what is computer. So now in this video we will see background of computer. It was in Babylonia around 2000 BC that the computer made its beginning as a simple calculator. The device, called the abacus, comprised a number of rings or beads that could be moved along rods enclosed by a wooden frame. This calculator could be used only for addition and subtraction, which were adequate for the age. Even though the device is still used in many countries of Eastern Europe and China, many other devices followed, each implementing a key computing concept that ultimately led to the creation of the digital computer. Napier, Pascal and Leibniz, the early pioneers. The next major leap in computing occurred with the invention of the logarithm by John Napier. In the early 17th century, Napier established that multiplication and division could be achieved by adding and subtracting, respectively, the logarithm of the numbers. Napier's invention soon led to the development of the slide rule, which was extensively used by engineers and scientists. Right up to the 1960s. NASA scientists used slide rules to land men on the moon and bring them back to Earth. This calculating device was eventually obsoleted by the electronic calculator, even though it has not completely disappeared. The 17th century also saw the emergence of the gear-based digital mechanical calculator. The slide rule is actually an analog device. Blaise Pascal was the first to create one, but it could perform only addition and subtraction. The stepped reckoner developed by Gottfried Leibniz improved upon Pascal's creation by adding the features of multiplication and division. Both devices were based on the decimal system, but Leibniz recommended the use of the binary system, which was to be adopted centuries later. The programmable computer. The concept of using a program to control a sequence of operations was first seen in the Jacquard loom in the early 19th century. This textile loom used a set of punched cards to weave complex patterns in the cloth. To weave a different design, one simply had to change the card set. This idea appealed to Charles Babbage, who used the concept in his two conceptual creations, the difference engine and analytical engine. However, while the holes in the cards of the Jacquard loom determined whether a thread would pass through it, Babbage saw an opportunity to use them to encode instructions and data. The analytical engine was fully automatic and designed to run on steam power. It had a processing unit and memory, two essential components of any programmable device. Apart from loops which allowed a set of statements to be repeated, the analytical engine featured a conditional statement, which would permit disruption of the normal sequence of operations. Babbage also utilized the services of Ada Lovelace, who designed a few algorithms for the engine. Even though neither engine was ever built, probably due to paucity of funds, Babbage is rightly considered to be the father of the computer, while Lovelace is accepted as the first programmer. When electric motors became available, Hermann Hollerith used the technology in the late 19th century to design the Hollerith desk. This machine featured a card reader, writer and gear-driven counter. The machine could count and sort data and display the output on a set of dials. Moreover, the machine could also punch output data onto the cards. Hollerith employed the Hollerith desk to complete the 1890 census in the USA, and his tabulating machine company, after consolidation, was renamed International Business Machines, IBM. In fact, IBM continued to make and sell these machines well into the 1960s before they were driven out by magnetic media. The programmable electronic computer. In the period leading up to World War II, most computers used electromechanical relays and switches to perform computation. The Z3 computer, designed by Konrad Zuse during the war, used over 2,000 relays. The Z3 is considered to be the world's first programmable and automatic digital computer. It was also the first computer to be based on the binary system, and program control was achieved by punched film. During the same period, the Colossus and ENIAC computers used vacuum tubes to be the first all-electronic programmable computers. However, a program in the Colossus or ENIAC was represented by the state of its switches, so reprogramming the machine for a different job needed manual resetting of these switches. Because of the difficulty of programming, speed was an issue even with electronic computers. This problem was addressed by Alan Turing, and later reiterated by John von Neumann, in the concept of the stored program computer. In a paper prepared in 1936, Turing reasoned that computer speeds could be vastly improved if both program and data were stored in the same memory. A program fed through paper tape couldn't be fast enough because the computer could only load one instruction at a time. This concept matches the present-day practice of using program and data in the same memory. In 1948-49, the Manchester Mark I became the first computer to implement the stored program concept. The 1940s also saw the dominance of the vacuum tube, also called valves, for performing computation. But these tubes generated a lot of heat, consumed enormous power and were notoriously unreliable. The 1950s saw the introduction of transistors which were smaller, generated less heat and were more reliable than vacuum tubes. Transistors too made way for integrated circuits, ICs, and eventually to the microprocessor which incorporated the entire CPU on a single chip. The rest we know as we seen. I think you understand the background of computer. In the next video we will see generations of computer. That's it for today. Thank you for watching.